NASA gave major information. Pluto isn't what you think. What is NASA proposing here? Are they gathering the most recent disclosures from the New Horizons space test, which shows that odd things are happening on Pluto's surface? One of the perilous pictures, for sure, shows something that seems to float across the external layer of Pluto. This raises upsetting inquiries about whether some sort of significant level dark life exists on this distant world, or are we dealing with a poorly understood geological phenomenon? Pluto may be small, but the records it holds to tell are colossal and loaded with surprises. When Pluto's planetary status was revoked in 2006, experts were unaware of the data from the New Horizons test, which had only just arrived at Pluto after years. Since then, we have realized that there is more to this smaller object than was expected. How did astronomers really come to deny this planet, which we have all, in some way, grown up with? Everything was happening with what was once a genuine planet. It had been that way until the discovery of several other small planets in the Kuiper Belt. Astronomers decided that we truly needed criteria for what constitutes a planet versus a dwarf planet or trans-Neptunian object. Pluto scored points for its size and round shape, but the planet shares its orbit with several other objects. The orbit is, therefore, not considered ideal. This was the justification for why Pluto was not regularly associated with the other major planets in the solar system. Many people on Earth believe this decision is a shame, and it caused widespread disappointment. The reclassification of Pluto as not a planet was a shocking concept for many. The fact that this small, unusual planet has so many fans on Earth led to letters of protest being sent to NASA from prominent scientists who opposed the demotion. Even state-run organizations received letters from residents requesting Pluto's reinstatement as a planet. Pluto's planetary status had been with us since the 1930s and was a fundamental part of a group of 9 planets. It was a cherished concept. This changed in 2015 when New Horizons sent back the first real images of Pluto. The images showed Pluto's beguiling face for the first time. Imagine it, the first genuine picture of Pluto. If you'd seen representations of the planet on posters or in school materials before, they were imaginative portrayals, not actual images. Pluto defied even the high-resolution images of the Hubble telescope, offering a clearer perspective on its surface. New Horizons was allowed to photograph Pluto as it truly is. Astounding, well-structured, and obviously rich with a heart. From that point onward, this planet on the outer edge of the solar system gained significantly more fans. Perhaps one day space experts will change their perspectives, and we will get Pluto back as a planet. The first confirmed images of Pluto took everyone's breath away. It was a prized moment when the initial data from the New Horizons test arrived at Mission Control in 2015. Everyone present knew they were about to see a planet for the first time. One that everyone was somewhat familiar with, yet had never seen up close. The computers on Earth assembled this mesmerizing image from vast amounts of data and pixels. What the test revealed about Pluto was a discovery that completely overturned our understanding of this distant world. Pluto is far more dynamic, structured, and alive than planetary scientists had previously imagined. Furthermore, the small planet appeared to be covered in fascinating features and unexpected natural oddities that no one anticipated. With each new piece of information that New Horizons provided, this dim, obscure world in the Kuiper Belt transformed into something remarkable. It showed such a burst of activity that it blew experts' minds. Gradually, astonishing geological phenomena emerged. Unlike the typically frozen and cratered dead landscapes, Pluto turned out to be a captivating place with extraordinary pieces of ice, deep canyons, and smooth, icy surfaces. One of the remarkable sights captured by New Horizons was the appearance of movement on Pluto's surface. In 2016, a moving image circulated in the media. It appeared to depict someone walking across a strange, honeycomb-shaped snow formation. However, this frozen surface is not made of water, as it would be on Earth, but of nitrogen and methane. Researchers identified this striking feature as a block of ice seemingly floating above the surface of the icy plain. The enormous block of ice is actually composed of extremely solid nitrogen. These peculiar landforms revealed something brilliant to researchers. They now believe there is a nitrogen supply several kilometers beneath Pluto's surface, where solid blocks form geological features within the planet. This process pushes the blocks upward, creating the honeycombs and fields, which resemble wandering mountains. This discovery points to a warm core within the planet, a hint that could have significant implications for how we interpret Pluto. This land development, influenced by heat and surface changes, suggests a kind of aliveness that indicates we have misunderstood Pluto. It shows not just stillness but also activity, and this could mean there are pockets of liquid beneath Pluto's surface, similar to oceans or magma. William McKinnon, leading the geology team for the New Horizons mission, compared the planet's interior to an enormous version of Hudson Bay in Canada. Simulations suggested that this striking landscape formed over millions of years and remains remarkably unique today. Sublimation, where a substance transitions directly from a solid to a gaseous state, likely created some of these unusual patterns due to Pluto's extreme temperatures. Incredible seasonal cycles and atmospheric changes also define Pluto. For instance, snow on Pluto consists of frozen nitrogen and methane, not water. These gases condense and fall as snow under Pluto's frigid conditions. This process shapes Pluto's surface, driving geological developments such as cryovolcanism. Sputnik Planitia, Pluto's heart-shaped feature, is particularly intriguing. This giant ice surface, covering an area of around 1,000 kilometers, is composed primarily of nitrogen ice. It suggests active geological processes beneath the surface. Beneath this smooth ice sheet, there may even be a subsurface ocean of liquid water. The possibility of life in these conditions, while uncertain, remains a fascinating question. Lastly, Pluto's relationship with its largest moon, Charon, adds complexity. Discovered in 1978, Charon is tidally locked with Pluto, creating a unique dynamic between the two. Its massive cliffs and impact craters contrast sharply with Pluto's more diverse surface. NASA's continued exploration of Pluto challenges our understanding of this distant world, revealing a more dynamic and enigmatic planet than we ever imagined. Pluto and Charon also share a fascinating exchange of materials. Over time, comet-like impacts and other interactions have caused a transfer of substances between the two celestial bodies. This relationship adds another layer of complexity to their unique dynamic. While Pluto was once considered the outermost planet in our solar system, it now stands as a testament to the evolving understanding of celestial objects and their classifications. The idea of Pluto having an atmosphere, even a tenuous one, was another revelation brought to light by the New Horizons mission. The thin atmosphere, composed of nitrogen, methane, and carbon monoxide, is influenced by Pluto's proximity to the Sun. As Pluto's orbit brings it closer, the sunlight causes the frozen gases on its surface to sublimate, temporarily thickening the atmosphere. Conversely, as Pluto moves farther away from the Sun, the atmosphere condenses and freezes back onto the surface. This cyclical transformation of Pluto's atmosphere not only highlights its dynamic nature but also contributes to the striking visuals of its surface. The variations in brightness and the distribution of darker, coal-like deposits suggest that Pluto's environment is continuously reshaped by these atmospheric changes. Even its mountains, composed of water ice rather than rock, behave differently due to the extreme cold, creating a constantly shifting landscape. The New Horizons mission also brought attention to the remarkable volcanic activity on Pluto, though it is vastly different from the volcanism observed on Earth. Instead of molten rock, Pluto's volcanoes release cryogenic materials such as water, ammonia, or methane. These cryovolcanic processes indicate that heat sources within the dwarf planet are still active, driving material upward to reshape the surface. One particularly compelling discovery involves the possible existence of a subsurface ocean beneath Pluto's icy crust. Scientists believe that residual heat from radioactive decay within the planet, combined with insulating layers of ice, may keep pockets of water in a liquid state. This finding raises intriguing questions about whether such an environment could harbor microbial life, even in such extreme conditions. Pluto's history is also etched into its surface, with impact craters serving as evidence of a long and tumultuous past. The distribution and size of these craters provide clues about the objects that have collided with Pluto over billions of years. However, the relatively smooth regions, such as Sputnik Planitia, suggest that internal processes have erased many of the older scars, hinting at an unexpectedly active interior. The broader implications of these discoveries have reignited discussions about the definition of a planet. Many scientists and space enthusiasts argue that Pluto's complexity and activity warrant reconsideration of its status. Despite its demotion to a dwarf planet, Pluto continues to captivate the imagination of researchers and the public alike. NASA's findings about Pluto serve as a reminder of how much there is still to learn about our solar system. The dwarf planet, once dismissed as a frozen, lifeless world, has revealed itself to be a dynamic and fascinating celestial body. Its unexpected complexity challenges preconceived notions and inspires a deeper appreciation for the diversity of objects that orbit our sun. As missions like New Horizons continue to provide unprecedented insights, the story of Pluto serves as a testament to human curiosity and the relentless pursuit of knowledge. It reminds us that even the smallest and most distant members of our solar system can hold profound secrets, reshaping our understanding of the universe and our place within it.